Today we start lecture number 8, layer 2 network design. Okay, so we have a layer 2 devices, okay, switches, hubs. So that connectivity with PC1, with core router, with ISP network, with Wi-Fi routers. There is a some network, okay. There is a create some network that called is network design. A small network, a big network, whatever. So a good network design is a modular and hierarchical with a clear separation of functions. Core, resilient, few changes, few features, high bandwidth, CPU power, then distribution, aggregation, redundancy, then access port density, affordability, security features, many adds, moves and changes. So these are contents of network design. Okay, core distribution and access. Core is related to bandwidth. Distribution is related to aggregation and redundancy network. One path, one path. There is a two path. Okay, one down, then second start automatically. Then third one is a access. Some security features are there. Okay. See, the ISP one. Okay, so ISP one means ISP Airtel, ISP Jio, ISP Tata. Then then this is a blue circle is a router. Okay, so there is a bandwidth storage router. Okay, so then manageable switch, manageable L3 switch, core switch that called. After that they used again core router. Okay, for customer distribution. See, the last one is a access. Okay, so access switches, which customer access the bandwidth from this ISP, ISP Tata, ISP Airtel. So this is the infra of internet. See, sometimes we have two ISPs. Okay, so ISP one is a Tata, ISP two is Airtel. Same, there is a two both having two bandwidth routers. Then core switch for distributing. After that, again they deployment of routers. Okay, for bandwidth capping, bandwidth distribution. Then access switches. These are redundant. ISP1 down, then ISP2 is working on this backhaul network. In building and layer 2, there is usually a correspondence between building separation and subnet separation. Okay, switching inside a building, routing between a building. Okay, in two buildings there is a routing features enable, and a single building in a switching features is enabled. Okay, this will depend on the size of the network. Very small networks can get by with doing switching between building. Then very large network might need to routing inside building. So switching and routing, these are both different concept. Layer 2 protocols basically control access to a shared medium, copper, fiber, electromagnetic waves. Ethernet is the de facto wire standard today. Okay. So Ethernet, you know all what is a Ethernet. Okay. And what is a wireless technology? So wireless technology also layer 2 technology that includes standard of 802.11 ABGN. Okay. So latest band is N. So point is clear. Layer 2 Ethernet and wireless technology. Sriram Tagore, Karthik.
Yes, sir.
Okay. So the source and destination identification MAC address. Detect and avoid frame collisions. Listen and wait for channel to be available. If collision occurs, wait a random period before retrying. This is called CSMA CD, means carrier sense multiple access with collision detection. That is a Ethernet function. See the Ethernet frame. SFD destination address, source address, and cyclic redundancy check. Okay. So here is a data CRC. So first one is the preamble 7, SFD, DA6, destination address, source address, type length, data. What is the data? 46.1500. This is a transmit unit, MTU. Okay. You know about MTU, maximum transmit unit. Then last one is a CRC. CRC means what is that SFP or physical connectivity is drop down. It is up down. Why up down? That is a power level connectivity, plug and unplug issues. So that is a CRC checking. See, evolution of Ethernet topologies. First one is a bus. Everybody on the same coaxial cable. Then star topology. One central device connects every other node, first with hubs, later with switches. Okay, then structured cabling for star topology standard. So these are type of Ethernet topology. This is a very old topology, primary topology, bus star. Switch star topology benefits. It's a modular, independent wires for each end node, independent traffic in each wire. A second layer of switches can be added to build a hierarchical network that extends the same two benefits above. The next hub. Hub like before switches we used two hub. Okay, so receives a frame on a one port and send it out every other port. Okay, so this is a very similarly broadcast on every port. Okay, so collision domain is not reduced. Traffic ends up places where it's not needed. See, this is hub. Okay, port 1, 2, 3, 4, 5. A frame sent by one node is always sent to every other node. So hubs are also called repeaters because they just repeat what they hear. So so this frame also communicate with this second port, third port, fourth port, fifth port. Then fifth port, this frame also repeat on 4, third, 2, 1. So many confusion with this hub. So that called is repeaters. So very confusion device is hub, but that is a primary network uh, content network device. Okay, after hub we learn about this switch. Okay, so learn the location of each node by looking at the source address of each incoming frame, and that builds a forwarding table. Forwards each incoming frame to the port where the destination node is, reduces the collision domain, makes more efficient use of the wire. Nodes don't waste time checking frames not destined to them. Okay, so these are benefits of switch. This is main role of switch. That's create the forward each incoming frame to the port where the destination node is. See, forwarding table in layer 2 switches. You know what is a ARP table, forwarding table. This is a ARP table, address and port number. So port A, okay, so that port A MAC address A, that is a port 1. Then port B, that is a some information about the port number 5, and that MAC address is a different PBB. So this is ARP table of layer 2 switches, and this is the main facility of this switch in this switch. See, a switch broadcasts some frames when the destination address is not found in the table, when the frame is destined to the broadcast address FFFFF. This FFFFF is a broadcast address. Okay. When the when the frame is destined to a multicast Ethernet address, so switches do not reduce the broadcast domain. So broadcast address is a FFFF. See, switch versus routers. So routers more or less do with IP packets what switches do the Ethernet frames. So Ethernet having frames, okay, and routing hand packets. A router looks the IP packet destination, okay. So in routers they forward IP packets, okay, and in switches they are forwarding frame. So that is a difference. So a router looks at IP packet destination and checks its routing table to decide where to forward the packet. Okay, so some differences below. IP packets travel inside Ethernet frames. IP networks can be logically segmented into subnets. Okay, then third one is the switches do not usually know about IP, so they only deal with the Ethernet frame. Okay. So point is a clear between switches and router. Tagore, Sriram, and Karthik. Hello, no any confirmation received. Tagore,
Yes, sir. Clear, sir.
clear. Okay.
Yes, sir.
See, again, there's some difference about switches and routers. Routers do not forward Ethernet broadcast. Okay, so switches reduce the collision domain and router reduce the broadcast domain. Okay. This becomes really important when trying to design hierarchical scalable networks that can grow sustainably. Switch, router, switch. Traffic domain. Router mostly used by bandwidth distribution, internet distribution, uh, mean some, what is that? Some different two different network. Okay, so can manage this router. So there is a two different network. Okay, one network with connected with switch 1 and second network is connected with switch B. See, so that switch used by hub, after hub used by PC1, PC2. Okay, so second hub PC1, PC2. Same scenario with another diagrams. Okay, switch hub and PC1, PC2. So there is a collision domain and broadcast domain. Okay, hub. So hub creates a collision because that same packet communicate to each other. Okay, but switch, in switch scenario there is a broadcast domain. They they forward broadcast to another port and stored MAC address with port number. So that is a traffic domain. Try to eliminate collision domains, get rid of hubs. Actually, hubs are very rare today. Yes, mostly that is a very rarely used by any network people. Then try to keep your broadcast domain limited to no more than 250 simultaneously connected hosts. Segment your net using routers. So always connect hierarchically if there are multiple switches in a building. So use an aggregation switch. Okay, so aggregation layer 2 switch. Locate the aggregation switch close to the building every point. Locate edge switches close to users. Okay, so maximum length is cat 5 or cat 6 is 100 meters. Okay, so two layer 2 switches between cat 6 is used by 100 meters. So building to building, building A to building B. See, this is a path elements. So first diagram path is a wrongly method, and second one is a, see, the central node is connected with the left and right node. Okay, and with down node similarly. So that is a perfect path. Small, this is a small network. This is a fiber link distribution switch. Okay, so this fiber connected to this switch, and this switch connected to this host via cat6 cable with 100 meters. So these are the main link is a fiber link that is a 1 kilometer to 20 kilometer. Okay, so incoming by this switch, and after switch that 1 2 3 4 5 host connected with 100 meters. So that is a small network, small build. As you have demand and money, grow like this. See, so same this fiber link, after we installed aggregation layer 2 switch, Okay, so after that, again we installed 20 kilometer or 15 kilometer or 10 kilometer fiber and install another layer to switch. Okay, so that is a fiber switch, also called fiber switch. Okay, because they are in a SFP module also and Ethernet module also. For Ethernet, 100 meter Cat6 PC1, PC2, PC3. Okay, and fiber out for 10 kilometer, 15 kilometer, 20 kilometers. So that is a aggregation switch, layer 2. See the same and keep growing within the same hierarchy. So main ISP fiber link incoming this aggregation switch. That aggregation switch divided distributed to two other switches. Okay, and also that aggregation switch is create three hosts. Okay, PC1, PC2, PC3. So in this way, this bandwidth distribution is successfully created and working fine condition. Okay, so this point is clear. Sri Ram, Tagore, and Karthik, aggregation switch, host switch, what is a fiber link and what is a Cat6 link.
Yes, sir.
Okay, so basically see, at this point you can also add a redundant aggregation switch. So this is a redundant aggregation switch. Okay, because there is now some features available in layer 2 aggregation switch. Okay, so there is a two paths. After one down, second path is working properly. So that is the same design network. Okay, aggregation. See the first aggregation to second aggregation to third normal switch. So that's why that is a small ring network, redundant network. This is the temptation of doing this. So see this network topologies are created wrongly. See, and this is a perfect because this is a main aggregation switch. Okay, so main aggregation switch, after main aggregation switch, the normal switch. Okay, after normal switch you install some PC1, PC2 or some network, some servers actually. See, here is a no any aggregation switch and switch to switch. There is a totally broadcast and collision network. So this is perfect. See, virtual LAN, VLAN. You know about the VLAN and you configured as well. So allow split switches to separate virtual switches. Only member of VLAN can see the VLAN traffic. Inter-VLAN traffic must go through a router. So VLAN, what is the VLAN role in our layer 2 switches, aggregation switches? See, there is a traditional VLAN segment, VLAN 1, VLAN 2, VLAN 3. Okay. This is shared hub, floor 3, floor 2, floor 1. Okay. So VLANs, how to VLAN segment? VLAN 2, VLAN 2, VLAN 1, then VLAN 3. Okay. Same scenario in third graph. Floor, first floor, second floor, and third floor. Created for VLAN 1, VLAN 2, VLAN 3. So basically, VLAN provides segmentation based on broadcast domain. VLAN logically segments switch network based on functions, project teams, or application of the organization regardless of the physical location or connections to the network. Then all workstation and server used by a particular work group share the same VLAN regardless and the physical connection or location. So that why we are using for this particular different VLAN. See, local VLAN. Two VLANs or more within a single switch. VLAN address scalability, security, and network management. Routers in VLAN topologies provide broadcast filtering, security, and traffic flow management. Edge ports, where end nodes are connected, are configured as a member of a VLAN. The switch behaves as several virtual switches, sending traffic only within VLAN members. Switches may not bridge any traffic between VLANs as this would violate the integrity of the VLAN broadcast domain. Traffic should only be routed between a VLAN. So these VLANs basically deployment of this way. See local VLANs, switch VLAN X and VLAN Y. This is a H port. Okay, and this is a VLAN Y nodes, VLAN X nodes. These species work with VLAN X and some these species work with VLAN Y. Okay, so that is a H port in layer 2. And these are member of VLAN X and these ports are member of VLAN Y. See, broadcast domain with the VLAN and routers. So without VLANs, see that the routers connected with this some switches and this switch these switches connected to some PC1, PC2, PC3, engineering, marketing, and sales. See the IP address 10.1.00, 10.2.00, 10.3.00. Okay. So without VLAN, each group is on a different IP network and on a different switch. Using VLAN, switch is configured with the ports on the appropriate VLAN. Still, each group on the different IP network. However, they are all on the same switch. Okay. See, with VLANs, this router connect to this switch and we create some VLANs. Okay. So engineering VLAN, marketing VLAN, and sales VLAN. Okay. So here we are using three different switches and here only using only one switches for we are distributing via VLANs. So that is the benefits. See, it's a switch one. Okay. So this connected with VLAN one, this connected to VLAN two, this PC connected to VLAN one, and this connected to VLAN two with the IP address. The port VLAN, the member of VLAN one, member of VLAN two. So important notes on the VLAN. VLANs are assigned to the switch ports. There is no VLAN assignment done on the host usually. In order for the host to be part of that VLAN, it must be assigned an IP address that belongs to the proper subnet. Remember VLAN subnet. So every layer 2 switches is working with by default VLAN 1. Okay. So when we create VLAN 2 or VLAN 3, so that also switch port a member of VLAN 2. Two VLANs is two subnet. See, VLAN 1 subnet is different 172.30.1.21. Okay, and here is a 21 IP and here is 172.30.1.23. Okay, so this is a 255.255.255.0. This is /24 mask. And with VLAN 2, there is a different IP address. See, 172.30.2 and with VLAN 30.1. Okay, so we create different, so we used different subnet for this VLAN 2. Okay, so we can't use same subnet, some IP address on some another VLAN. Okay. VLAN separate broadcast domains. For example, without VLAN, the ARP would be seen on all subnets. Assigning a host to the current VLAN is a two-step process. Connect the host to the correct port on the switch and assign to the host correct IP address depending on the VLAN membership. Okay, so ARP request, see the ARP request. What is the ARP request in switch 1? Okay. So this IP address and this MAC address with port number 3 and port number 1. So that is a communication. Same scenario with VLAN 2. Okay. So port number 4 and 6, 4 and 5. VLAN operations. As the device enters the network, it automatically assumes the VLAN membership of the port to which is attached. The default VLAN for every port in the switch is VLAN 1 and cannot be deleted. Okay, so VLAN 1 is a by default VLAN. I discussed this VLAN 1 concept. So the default VLAN for every port in the switch is VLAN 1 and cannot be deleted. Okay, so all other ports on the switch may be reassigned to alternate VLANs. VLAN across switches. Two switches can exchange traffic from one or more VLANs. Okay. Then inter-switch links are configured as a trunks carrying frames all or subsets of a switch VLANs, and each frames carries a tag that identifies which VLAN is belong to. Okay. So trunk VLAN and access VLAN also we learn. See the diagram. The first diagram is a VLAN 1, some another another link with VLAN 1, and there is a separate link with VLAN 2. See, so VLAN 1 and VLAN 2. After VLAN tagging, we use only one fiber link. See, and port is a trunk. This port trunk carrying VLAN 1 and VLAN 2. Okay, see. So VLAN tagging is used when a single link needs to carry traffic for more than the one VLAN. Okay. So here benefit of benefit of this single link with trunk port. So Tagore Karthik, clear the VLAN tagging and VLAN trunk point.
Yes, sir.
Okay. See, tag frames. Okay, 8021Q is a trunk protocol for IEEE standards. VLAN trunk port is a VLAN X and VLAN Y H ports. So same scenario VLAN X and VLAN Y with this is called VLAN trunking because both VLAN we used in same link. See, the IEEE standards that defines how Ethernet frames should be tagged when moving across the switch trunks. This means that switches from different vendors are able to exchange VLAN traffic. See the tag frame. Normal Ethernet frame. Okay. This is normal preamble, some data, SFD, then destination address, source address, type of length, data MTU size, CRC. But what is the tag frame? Okay, so in tag frame there is a two TPI and tag. See the number of tagging. So which number? VLAN 2, VLAN 4, VLAN 5, any. Okay. So this is a possible VLAN 12 bit 12 bits VLAN ID to 124096. That is the range of VLAN. Tag versus untagged. H ports are not tagged. Are they just member of a VLAN? Okay. You only need to tag frames in switch to switch links, trunk links. When transporting multiple VLANs, a trunk can transport both tagged and untagged VLAN as long as the two switches agree on the how to handle those. Okay. So we create a some VLAN for our manageable layer to switch. Okay. So VLAN 20, VLAN 30, VLAN 40. So port number 2, port number 3, port number 4, and these VLAN trunking carry to port number 5. VLAN increase complexity. You can no longer just replace a switch. Now you have VLAN configuration to maintain field technicians and need more skills. You have to make sure that all the switch to switch trunks are carrying all the necessary VLANs. Need to keep in mind when adding and removing VLANs. So you need to know which VLAN you to add and which to remove. Good reason to use VLAN. You want to segment your network into multiple subnets but can't buy enough switches. Okay, so height sensitive infrastructure like IP phones, building controls, etc. Separate control traffic from user traffic. Restrict who can access your switch management address. So we can distribute our internet, our voice. Okay, so our internet and data voice is a multiple services with VLAN. So VLAN 100 is working with internet and VLAN 200 is working with IP phone with voice. Bad reason to use VLAN. Okay, so because you can and you feel cool because they will completely secure your host or so you think because they allow to extend the same IP network over multiple separate buildings. So this is very but no any challenges for them. Extending a VLAN to multiple building across trunk ports. This is a bad idea because broadcast traffic is carried across all trunks from one end of the network to another, and broadcast storm can spread across the extent of the VLAN. Maintenance troubleshooting nightmare. Okay, so you have to manage that which VLAN you forwarded, which VLANs you implementation on your network. So you have to proper network engineer. You have to proper maintain VLAN data to execute. Okay, so configuration is done before. Okay, so Karthik, Shriram, Tagore, any issues about this network design? What is the how to implementation network design with VLAN? Any issues, any doubts? Please ask. Okay, so any issues?
No, sir.
So concept is clear with what is a layer 2 network design. Okay,
Yes, sir. Clear, sir.
okay. So tomorrow I some give you create a some lab, okay, and some VLAN, okay.
Okay, sir. Okay, sir.
So tomorrow we start our lecture 9, okay. So today lecture 8 is completed.